let's talk about the big picture first, okay, of where we're going to go with this. But I'm going to go to the end first, and then I'm going to go back to the beginning so you can see where we're going to go with this. All right, we're talking quality assurance, as Keith had just mentioned a few minutes ago. All right, Section 10.2.2 of the code specifically says construction documents shall include testing and inspection requirements applicable to the project, just like 318. Would you do a new building without cylinders? Would you do a new building without testing? No. So when you do a repair, quality assurance testing is also being required. The commentary specifically says the repair inspector qualifications for inspection should be by certification. And it also says an individual who has been certified as an ICRI concrete surface repair testing technician, the ICRI program, is certified to do the inspection. That's where we're going. Okay? So who is this repair technician? Who is the guy or the person? All right? First of all, repair technician is not the licensed design professional. That's the engineer of record. Okay? That's not the repair technician. All right? It can be, but that's not the definition of the repair technician. 562 code is specifically written towards the licensed design professionals. It's not written for, I would say, a major portion of us here in ICRI. Okay, the major portion being the contractors, the people that are implementing the work. Not written for them. It's written for the licensed design professional. As Keith just went through, you've got all the design requirements. So let's try to talk about who that repair technician is and how the code talks to the repair technician. All right. In the code, just to reiterate what I said, in the very first page of the code, it specifically says that this code was to provide the design professionals guidance, okay? Not us as the repair people. So let's go farther. It also talks about the responsibility of the licensed design professional. I'll just go really quickly on what that is. It goes through all the listing of the licensed design professional. You see nothing in here about the construction and the quality assurance person, all right? So the commentary goes into it and says the quality of concrete repairs is largely dependent upon the workmanship during construction. So we're starting to see language in the code telling us why we've got to go here. And of course, it also says inspection is necessary to verify repairs and rehabilitation work are completed. Here again, just like in new construction, you wouldn't do new construction without quality assurance testing. So the commentary of the code is already guiding us towards the need for quality assurance. All right, so let's get a real definition of who the repair technician is. He's the qualified he or she is the qualified person to inspect the quality of the work. That's the person we're talking about. Okay? From the owner's side, that's the quality assurance inspector. All right? From the contractor side, it's the quality control person. From the ACI-562 side, it's actually both of you. Okay? That's the certified person qualified to do the inspection. That's where we're going here. Okay? Let's talk about the knowledge that the repair technician has to have. Okay? What does that individual need to know? We'll take a look at some examples. First, condition assessment. There's methods of assessment. The repair technician has to know the different methods. You're going to do a chain drag, you're going to do non-destructive testing, you're going to do other things. That's important to know. There's the chain drag. It has an ASTM standard. Still have to be familiar with it if you're going to do it correctly. We have exploratory removal. All of us know how to take concrete out with jackhammers, but that's part of condition assessment. We have impact echo. How many here know impact echo? Okay, it's a technique. It's an important one. We have impulse response. I'm sure there'd be less hands I see asking for that. Thermography is a technique. Now, let's take a look what the code says about it. So in the commentary, it says the primary purpose of construction observation is to verify the exposed existing construction is as assumed in the design and that the work detailed in the contract documents will fulfill the design intent. So that means this repair technician has to understand that. Have to be knowledgeable about the design, why the design is being done, and what's being repaired. So the code is now talking to you as the repair technician. Bond. As Keith said, bond is a primary thing. Just think of this. Virtually everything we do in the repair world is related to bond. Everything. You do a surface repair, you do a vertical repair, an overhead repair, you do FRP. Everything is related to bond. So the repair technician has to understand bond, and I'll talk a little bit more about it later, and has to understand ASTM 1583 for the bond testing. We'll talk some more about those later. All right. Causes of the concrete deterioration. There's embedded metal corrosion. I'm sure everybody would raise their hand if they understand embedded metal corrosion. Okay, but there's some other things. Freeze-thaw damage. We have erosion and abrasion. One must understand that if one is going to be fixing it or inspecting the quality of the repair for that. Disintegration of concrete. What are the mechanisms that cause concrete to disintegrate? And let's see what the code says about it. So in section 1.7.4, I highlighted in yellow the effects of material deterioration and other deficiencies. Now that's talking to the licensed design professional, but it's also talking to the repair technician. You must understand this. If you don't understand it, you're not going to be understanding the repair. The knowledge of why a repair is being performed is absolutely imperative for understanding what's to be repaired. What is being repaired in this building? How is it going on? So if you have that knowledge, you have the ability to observe if a repair is being completed correctly. That's the primary piece right here. Carbonation and chloride contamination. I assume you all know that chlorides are going to be detrimental. But you must understand that as the repair technician. So corrosion of the reinforcing steel can be initiated by either of those two. That's a whole seminar by itself. But the repair technician has to understand that. Of course, in the code, it's saying concrete has to have the in-place properties of concrete are in Chapter 6. But it talks about the extent, and in the commentary, the extent and cause of the deterioration, and of course the concrete strength and quality should be assessed. Goes through all the other things, of course carbonation and chloride are included. And then the commentary ends with chloride penetration can cause corrosion, but we all know that. Repair technician absolutely has to be aware of that. Concrete removal. There's different ways of taking concrete out. But how many people here would know when I say a re-entrant corner can cause a crack? Very few hands came up. Okay, I got about a third of you. All right. Cracking can be detrimental. Of course, cracking can be okay too, but one has to understand the repair geometry in relation to cracking, in relation to the specifications. Of course, the licensed design professional also needs to know this because the licensed design professional has to be designing the correct repair geometry. But the repair technician has to understand that. Undercutting of reinforcing steel. Does a bar get undercut or does it not? What's the rules? Repair technician needs to understand that. And of course, the code is saying the repair geometry is important. That's, of course, talking to the licensed design professional, but here it's also talking to the repair technician. More on concrete removal. In the code itself, it's specifically saying the shape of the repair should be considered to reduce stress concentrations and possible cracking. That's the piece that the repair technician has to understand. And it's also described in ACI 310.1, so there's plenty of guidance on learning about this. Methods of removal. How do you actually take the concrete out? There's jackhammer, of course, hydrodemolition. We've got the saw cutting on the perimeter. We have to understand all of these pieces so that you know, is it being done correctly? The surface chips. How many engineers specify a specific surface profile using the surface chips? That's good, okay? Now the repair technician must also know that. So the repair technician has to know how to use those in order to verify has it been done correctly. Bruising and microfractures affecting bond, another issue from the repair technician. The code on this specifically says required testing may include concrete removal and surface prep of the concrete and the reinforcement. So here's what the code is telling us as the repair technician, what the repair technician needs to be looking at. All right, surface preparation. I just talked about the bruising. The cleanliness of the concrete. Is it clean enough or is it not clean enough? What about temperature? Did we exceed our temperature limits? And how does one measure the temperature? And of course, moisture. What's surface saturated dry? That's a tough one, somewhat, because there's no real absolute standard on it. But that's often used as the specification. So the repair technician needs to understand all of these four things on the surface preparation. More on that commentary, it talks about mixing, placing, and curing of the repair materials. All right, let's talk about the cementitious replacement material itself. Material selection. Is it the right material? Okay, the licensed design professional, of course, is going to be specifying it. But the repair technician has to look at that stuff, and is it the right stuff? Okay, so the repair technician has to be very familiar with the material selection. Compatibility. All right, the licensed design professional may have just said 4,000 PSI concrete. All right, but is that 4,000 PSI concrete that's being supplied for this job with the additives in this concrete, is it compatible with the base concrete? Or did the contractor supply a bag material that's different? Is it compatible? The code specifically says the design of the repair system shall consider the properties and installation of the repair materials and systems. Okay, that's going to the licensed design professional, but here's the key pieces: the physical properties of the repair materials, and you can see all the others that go along with it. So it's very important for the repair technician to understand the material that's going in place. All right, methods of placement. How do we put this stuff in the hole? All right, there's dry packing. We've got all these different methods of placing concrete. All right, did the contractor choose the correct one for that application? And of course, the code says the required testing and inspection may include delivery, placement, identity, quantity, and location of the placement. So here the code is telling the repair technician what he or she must be looking at during the construction. Of course, there's mixing, placing of the repair materials. All right, let's talk about concrete curing. There's methods of curing. Did the contractor do it correctly? Or how is it being done? Is it a curing compound? Are they doing an evaporation retarder? Is either one of them correct or incorrect? Burlap, you can use wet burlap. You can use polyethylene sheeting. There's a wet cure. Should that concrete have been cured by a wet cure method, or is another method okay? Of course, the code talks about it. It says the required testing may include curing of the repair materials. So it's telling the licensed design professional that the professional has to specify it, but the repair technician has to understand which method is being used and is it the correct method that's being used. Bond. As Keith said, bond is probably the hottest topic and the longest discussed topic of anything we did in the entire code when we put it together. Let's talk a little bit about bonding. We have mechanisms that affect the bond. Right. We talked about the surface chips. Is it the mechanical interlock between the concretes? Is the surface too smooth to get good bonding? Or is there bruising? A key piece in affecting bond. Did we get too many microfractures in the base concrete? The repair technician has to understand both of these, understand how to inspect for them, and make sure that the correct procedures have been followed and everything has been taken care of. We have the ASTM 4580 for sounding. We'll talk about integrity. There's two pieces here, that there's either integrity or there's quantitative, where the code talks about these different levels. So I don't need to go into that part, but when the engineer or the licensed design professional specifies that it's going to be qualitative bonding, the repair technician is the person that's going to be doing it. When it's only specified to have integrity, we need to know how to do that. Now, what's the difference between the two? Integrity is a yes/no question. You can do a chain drag on a repair, and it's either bonded or it's not bonded. It's a yes or no answer, okay? But how good is that bond? You don't know that. With a chain drag, you don't know that. So if you do the bond pull-off test, then you know what the capacity is. All right, so depending on the different levels of design right here at 30 psi, the engineer of record will specify which one is necessary. Repair technician will not know the answer, is it 30, 60, or above 60. You won't know that. It's got to be specified. But once it's specified, the repair technician needs to know how to do that. And of course, in the commentary, it talks about how you do the testing. All right, a little bit more on the bond. We have the bond pull-off testing, as we just said. And here it is in the code, where the code tells you that the ASTM C1583, as described in ACI-210. Now, it's important to 210, because how many tests do you do? And where do you do them? I'm not going to go in through all of that right now, but that's a key piece. You have to know how many tests. Now, it should be in the specifications where you're going to be doing and how much, but sometimes it may not be. So as a repair technician, you're going to need to know how many tests you're going to be doing and where you're going to be doing them. Talk about the reinforcing steel corrosion. What is acceptable corrosion? How much can you have? How do you look for it? What's unacceptable corrosion? Now, yes, the licensed design professional has to have some guidance on it, but the repair technician has to know the stuff. When you're looking at the bar, when you see that rusting on the bar, when is that bar damaged? Is it damaged or is it not damaged? So the code, of course, is talking about the corrosion and deterioration of the reinforcing steel is important in the durability. But the key piece is, it says the ACI-310 provides guidance on removal of damaged concrete and cleanliness of the reinforcing steel. So those are key pieces that the repair technician has to understand. How many people in here have a good idea of how much corrosion can occur on a bar? If you're a certified repair technician, you have to know that. Okay, a little bit more on the reinforcing steel. Calculation of the lost cross-sectional area. Show of hands. How many people can calculate the lost cross-sectional area? Okay. And how many of you are licensed design professionals? More hands than the first time. Okay? So what I'm showing you is even the licensed design professionals don't all know how to do it. But if you're out there in the field and the specifications say you can have 15% or 5% or 10% loss of cross-sectional area, you better know how to do it. That's a key piece for the repair technician. Of course, the code says reinforcement that is damaged or corroded shall be permitted to remain. So what that says is the licensed design professional is fully capable of saying in his or her spec, you can have 15% cross-sectional area loss before you have to put in extra bars. That the quality control has to check, quality assurance has to check. More on from the commentary. The effective area is calculated using the remaining effective diameter of the reinforcing bar, accounting for the loss of section due to the corrosion. So that's given the licensed design professional the ability to say what is in the spec, but the repair technician has to understand that. More on reinforcing steel. So the corrosion removal. How do we get that rust off the bar? Did we do it correctly? Did we use a wire wheel? Did we use hand techniques, or did we use sandblasting? What's the correct method of getting that specific corrosion off of the bar? Is it the right way? Of course, the code is saying the corrosion and deterioration reinforcing shall be considered in the durability to design. So that means the licensed design professional took into account that we're trying to get a durable design. So the licensed design professional is telling you how much reinforcing has to be cleaned, and you have to be able to know that you've removed the correct amount. The code is, the commentary is also saying that the untreated reinforcing limits the life expectancy. So you're controlling it by knowing, did you get the right amount of reinforcing steel cleaned? And ICRI provides guidance. Another key piece to understand, 310. More on the reinforcing steel, concrete cover. I suspect if I asked how many people know what the cover is, just about everybody would probably put their hand up. But it's an important piece. You must be able to know how to measure the concrete cover over the bar, and that's about the corrosion protection. Let's talk about the replacement. Development length. If I ask the engineers in the room, every one of you should know what's development length. But I have to ask the contractors in the room, how many of you know what is development length? Okay? There's only a few of you that know. I'm not going to go into it, but it's a key piece. You must understand when you're putting in a new reinforcing bar, how far that bar is into the concrete to know that it's been developed. The engineer of record will specify for you your development length, but you need to know how to measure it. Same thing with the lap length. That's a little bit easier, but you must know how to measure the lap length, bar size, and the strength of the bar. There's alternate methods of splicing. What if we can't get the correct lap length and they choose to use a mechanical splice or a welded splice? Is it the correct splicing material? Did they get the right piece that can take care of the amount of lap length that should have been there? And of course, the code is saying the construction documents should include size, configuration, and reinforcing. I mean, that's a no-brainer. And here it says specifically development length of the reinforcing and the length of your lap splices. So those are important pieces for the engineer, and it's important pieces for the repair technician. Let's talk about the testing. Specific testing. Repair technician has to know about ASTM 1583. We just talked about that on the bond testing. Slump. Now, 318 and 562 are very similar in some of the testing. If you do a new construction, would you ever think of doing new construction without measuring your slump? Well, if you're doing repair and using that same concrete, why aren't you measuring your slump? So some engineers will be specifying it. In self-consolidating concrete, it's that spread. But the same test, everybody needs to know how to do that if you're a repair technician. And of course, your concrete test specimens in new construction, again, you wouldn't think of doing new construction without taking test cylinders. So why would you be doing repair without taking test cylinders? Repair technician needs to know this. The commentary in the code says, of course, the repair construction should be inspected to verify the quality of the materials and quality of the workmanship. So it's talking to the repair technician, although it's intended for the licensed design professional too. Tests of the repair material should comply with testing and frequency of new construction. Now that's a commentary. That's not a code requirement. But it's still pointing to you as saying, if you're going to do new concrete, you should be testing your new concrete just like you would in a new building. Here's the big picture. As I said in the beginning of this, let's go to the end first and back to the beginning. Well, we're not quite at the end. We're getting there. Okay, we're close. But on the big picture, we're talking quality assurance. Construction documents shall include testing and inspection requirements applicable to the project. So that's telling you licensed design professionals, thou shalt specify testing and inspection, just like you do in new construction. So in repair, we have to have quality assurance inspection. The commentary specifically says, demonstrated by certification, and is mentioning ICRI specifically. There's one other reference, it's the ACI, 306. Okay, the ACI-306, but that's really a reference for new construction. That really doesn't talk about concrete repair. The only thing it talks about concrete repair is the ICRI certification program. And that's what we just defined. I just went through with you, defining for you, the ICRI Surface Repair Technician program. Okay? So for those of you in quality control, quality assurance, here's how you can learn. There's something else that's very interesting, and I'll show you the, what's in the program in a minute. How many of you are first-timers here? Okay. How many of you are new to concrete repair? Okay. How many of you are employers? Okay. And those employers get new employees occasionally and want to learn in this industry. If you send them to this program or have them do this program, you learn an awful lot about concrete repair in a very, very short period of time. Okay? So there's another sidebar here to the certification program. You can learn an awful lot about this industry if you do the certification program. It's 8 hours long for the first tier. There's 2 tiers to it. So I'll briefly tell you about what the program is. The first tier consists of 5 training modules. Now, there's been some other seminars really going into the full program, and I'm not going to talk about the full program. But there's 2 tiers, and it's that first tier, and you end up with a certificate of achievement. Okay, that's not the full certification, but it's 8 hours long. I've taken this test. Okay, I helped develop it, and I've also taken it. I passed. Yeah, I think so. And it really goes into the basics. I mean, going down to the basics of how is concrete made? What's the difference between concrete and mortar? Okay, so it goes into the real basics. It goes into the corrosion. It goes into why the corrosion causes the damage. So the repair technician has a full understanding not only of how to inspect it, but why it's occurring. And if the repair technician understands why all of this is occurring, then they can understand how to check it. So there's a lot to it, and it's got some really, really good basic stuff. As I said, there's the 5 modules, and you can see what all the 5 modules are here. And each module, it really does take 2 hours to do it, to go through it. The second tier is the full certification. That's where you have to pass the first tier, and then you can take the second tier. And in the second tier, you do either a live demonstration of doing the tests. All right, I'll show you in a future slide. The bond pull-off test, you have to do it, okay? And you have to do it in front of somebody, and that person has to test you and make sure you're doing it correctly. You have to do a slump test. You have to do the self-consolidating tests. Self-consolidating concrete test for the spread. And of course you have to take cylinders. So you have to do those 4 tests in front of somebody if you're doing it live, or you can get a video camera. You rent a kit that includes a video camera, and you take a picture of yourself doing it. Okay, so once you pass that, then then it's known that you not only know what's going on, you know why things are going on, you know how to inspect, and then you know how to do the tests. That's your full certification. So as I said, it's got the second tier has the knowledge exam of the first, and then that performance, which is the live video. Okay, so here's the 4 tests that you need to do. Okay, and you need to do those again, as I said, either live or doing it as a video. So who is the repair technician? It's not the licensed design professional, as we said. It's the ICRI certified concrete repair technician. That's who's the repair technician.